Everyone, let us do some assertion. Recent question from Unit 4 Chemical Kinetics. First question: hydrolysis of methyl ethanoate is a pseudo first order reaction. We know the hydrolysis equation: ester plus water gives acid plus alcohol. Acid plus alcohol. So here we can write the rate law expression, rate equal to K into concentration of ester into concentration of water. Here the concentration of water remain constant throughout the reaction because water is present in large excess. So we can write K dash into concentration of water, you can write it as K. So we can replace K into H2O or K dash into H2O by using K. So we can rewrite the equation rate equal to K into concentration of ester. Here rate of the reaction depends upon only concentration of ester. So that's why it's a pseudo first order reaction. So both assertion is correct and reason also correct. So correct reason is the correct explanation of assertion. So our option is option A. Second question: the slowest elementary step in a complex reaction decides the rate of the reaction. In a complex reaction, rate is determined by the slowest step. So assertion is correct. Slowest elementary step always has smallest molecularity. That's not always true. So that's a wrong statement. So assertion correct and reason wrong, option C. Now third question: a catalyst increases the rate of reaction. We know catalyst always increases the rate of reaction by reducing the activation energy, but reason is given that catalyst increases the activation energy. We know when we use a catalyst in a chemical reaction, reactants and products, in an exothermic reaction, we know reactants are having more energy than products. Reaction coordinate, when we plot potential energy against the reaction coordinate, energy of reactants and products, this plotted without catalyst, and without catalyst the activation energy is this much, but when we use a catalyst the activation energy decreased. So catalyst always decreases the activation energy. So assertion correct and reason wrong statement. So our option is C. Next question: activation complex for the forward reaction will have lower energy than that of the backward reaction. So that is a correct statement. When we draw potential energy against the reaction coordinate, and when we compare the energy of reactants and products for an exothermic reaction, we can see that activation energy for the forward reaction is this, but activation energy for the backward reaction, this is the activation energy for the backward reaction. So activation energy for the forward reaction is lower than that of backward reaction in an exothermic reaction. That statement is correct statement. And reactants have great energy than products. Both assertion and reason both are correct statement, and reason is the correct explanation of assertion. So our option is A. Fifth question: increasing temperature increases the rate of reaction. Yes, that's correct statement only. According to Arrhenius equation, K is equal to A e raised to minus EA by RT. So for every 10-degree rise in temperature, the rate constant gets doubled. So increase in temperature increases the rate of reaction. That's correct statement. And also more colliding molecules will have energy greater than threshold energy. So that statement is also correct. So assertion and reason both are correct statement, and reason is the correct explanation of assertion. So our option is A. Sixth question: unit of rate constant is independent of order of reaction. So that statement is wrong statement, because we know rate constant depends upon order. So rate constant unit will vary with the order. Order of zero order is not same as order of first order reaction. So we know that. So it always depends. The power of concentration terms in the rate equation keep changing with the change in order. That's correct statement. So assertion is wrong and reason is correct statement. So our option is D. Then seventh question: Increase in concentration of reactant will not change the rate for a zero order reaction. That's true, because rate is equal to K into concentration of reactant raised to the power 0 for zero order reaction. So this statement is correct statement. And rate constant for a zero order reaction is constant for a particular initial concentration. That's also true, but reason is not the correct explanation of assertion. So our option is B. Assertion and reason both are correct statement, but reason is not the correct explanation of assertion. Now, eighth question. Half-life of a reaction is independent of initial concentration of first order reaction. So, T half is equal to 0.693 by K. So, we cannot see any concentration term in the T half equation. So, this statement is correct statement. The integrated rate law for a first order reaction is independent of initial concentration. So let us write the rate constant integrated rate law equation. We can derive minus dr by dt is equal to K into concentration of R raised to 1, and finally you will get K is equal to 2.303 by T log R0 by R. So from this we can conclude it depends upon the initial concentration R0. So integrated rate law for a first order reaction depends. So this is a wrong statement. Assertion correct and reason wrong. So our option is C. Now eighth question. Half-life of a reaction can be used to predict the order of a reaction. It's true. Then relationship between half-life and initial concentration of reactant is dependent on order. So that statement is also correct. Assertion and reason both are correct, and reason is the correct explanation of assertion. So our option is A. Next question. Assertion, order and molecularity are same. So order and molecularity are not same, because order is an experimentally determined quantity, and molecularity we are just adding the sum of the stoichiometric coefficients in the rate law expression. So that both are not same. Because of that we can say assertion wrong and reason correct. So our option is D. Then 11th question. Enthalpy of a reaction remains constant in the presence of a catalyst. So when we use catalyst, the enthalpy of reaction. So this one without catalyst and the second one with the catalyst. Okay. So we used catalyst in both first case without catalyst and second case with the catalyst. But you cannot see any difference. Both the case delta H remains constant. So enthalpy of a reaction remains constant. That statement is correct. A catalyst participating in the reaction forms different activated complex and lowers down the activation energy, but the difference in energy of reactant and product remains the same. That statement is also correct. So assertion and reason both are correct statement, and reason is the correct explanation of assertion. And 12th question, all collisions of reactant molecule lead to product formation. That is wrong statement. For proper collision, the molecule should have proper orientation and sufficient kinetic energy. That's the threshold energy. Then that statement is wrong statement. Only those collision in which molecules have correct orientation and sufficient kinetic energy lead to the compound formation. That statement is correct. So assertion wrong and reason correct. So our option is D. 13th question. Order of the reaction can be zero or fraction. Reason. We cannot determine the order from a balanced chemical equation. That statement is correct. But assertion statement, order of a reaction can be zero or fraction. Order is the sum of the powers of the concentration terms in the rate law expression. So assertion and reason both are correct statement, but reason is not the correct explanation of assertion. So our option is B. Then 14th question. Instantaneous rate is used to predict the rate of reaction at a particular moment of time. Instantaneous rate, that's R instantaneous, is equal to minus dr by dt. When delta t tends to 0, we can write the instantaneous rate. So it is at a particular moment. That statement is correct statement. Average rate constant for the reaction for the time interval for which is a constant for the time interval for which it is calculated. That statement is also correct, but reason is not the correct explanation of assertion. So our option is B. Then for the reaction CHCl3 plus Cl2 gives CCl4 plus HCl, we can write the rate law, rate equal to K into concentration of CHCl3 into Cl2 raised to half. So here we can see the coefficients are not equal because this equation is just a theoretical equation and this is experimental based result. Okay, so the statement is correct statement. Rate law for any reaction can be predicted with the help of balanced equation. It's not true always because it can vary. It may or may not be true. So the reason is wrong statement. So assertion correct and reason false. So our option is C. Next, the rate of a reaction is the rate of change of concentration of reactant or product. That's correct statement. Rate of a reaction remains constant during the course of reaction. That's wrong statement. Rate of the reaction keep on changing. So assertion correct and reason false. So our option is C. 70th question. The inversion of cane sugar is a pseudo first order reaction. It became pseudo first order because the concentration of water remained constant throughout the reaction. So that's why it became pseudo first order. H2O in this reaction is present in less amount. That's wrong statement. So assertion correct and reason wrong. So our option is option C. The next 18th question. For each 10-degree rise of temperature, the specific rate constant is nearly doubled. According to Arrhenius equation, K is equal to A e raised to minus EA by RT. For every 10-degree rise in temperature, the rate constant gets doubled. That's true statement. Energy-wise distribution of molecule in a gas is an experimental function of temperature. That reason statement is also correct, but reason is not the correct explanation of assertion. So our option is B. The 90th question. If the activation energy of reaction is 0, temperature will not have any effect on the rate constant. That is true according to Arrhenius equation. So we know energy of activation is 0. That term will be 0. So rate constant will not depend upon that term, or it will not depend upon temperature. That's correct statement. Then lower the activation energy, higher the rate of reaction. That's also true statement because we know if activation energy is less, more molecules can take part in chemical reaction. So, but reason is not the correct explanation of assertion. So our option is B. Then 20th question, rate constant determined from Arrhenius equations are fairly accurate for as simple as well as complex molecules. That statement is correct because we know according to Arrhenius equation for the formation of product, the molecule should have proper orientation and sufficient kinetic energy. So that statement is correct statement. Then reason, reactant molecules undergo chemical change irrespective of their orientation. That's wrong statement. Only the molecules with a proper orientation can take part in reaction. So our option is C, assertion correct and reason wrong. Then next question, the decomposition of gaseous ammonia on hot platinum surface is a zero order reaction at high pressure. That statement is correct statement. For zero order reaction, the rate of reaction is independent of initial concentration. That's also correct. But reason is not the correct explanation of assertion. We know at high pressure, the metal surface gets saturated with a gas molecule. So a further change in reaction condition is unable to alter the amount of ammonia on the surface of catalyst. So that's why rate of reaction is independent of concentration. So assertion and reason both are correct statements, but reason is not the correct explanation of assertion. So our option is option B.